All right, this is Fall Exam Review Worksheet 6. Okay, so start with number 1. What is a one-to-one function? So a one-to-one function is simply a function where each x value has one unique y value, and it's going to pass the horizontal line test. And its inverse is a function. So something like this, something that looks like y equals x cubed is a one-to-one function. Something that is not a one-to-one function would be like a parabola. Okay. With a parabola, there is not going to be a unique y value for an x for a given x value, and if and it's not going to pass the horizontal line test, which means that the inverse will not be a function because the inverse will not pass a vertical line test. Okay, what does monotonic mean? So it's just a function that's always increasing or always decreasing, again, like x cubed, okay, or negative x cubed. Okay. What is local maximum? So that's just another way of saying relative maximum, okay. Or local minimum or local extrema, same thing as relative. Okay. Number 2, radius of a sphere is increasing at a constant rate of 2 centimeters per second. At the instant when the volume of the sphere is increasing at 32 pi cubic centimeters per second, the surface area of the sphere is. Okay, so let's list out information that we know. So we know volume of the formula. We know the formula for volume. We know surface area is 4 pi r squared. Okay, let's see what's given to us. Radius of the sphere is increasing at a constant rate of 2 centimeters per second. So this is talking about radius, but it's a rate of change of radius. And it's increasing, so radius is getting larger, so we do want to make sure this is a positive rate. So positive 2 centimeters per second. At the instant when the volume is increasing at this rate, so volume increasing, this is dV dt, 32 pi cubic centimeters per second, the surface of the area is. So we're trying to find surface area at this moment in time. So we're going to have to deal with dV dt to get to dr dt and use this to help us find the surface area at this moment. So we start with volume formula. We find the derivative with respect to time. So v becomes dv dt. 4/3 pi, think of this as leading coefficient. R cubed, the derivative there would just be 3r squared, but we're involving r's derivative, so we got to attach dr dt. Okay, so let's see what we can cancel out and simplify. 3's cancel out, so we're left with 4 pi r squared dr dt. dv dt, we know the value for that, 32 pi cubic centimeters. Okay, and then dr dt gets replaced with 2. Okay, so now next step here, 32 pi is the value for dv dt equals 4 pi r squared times 2. Now if you look, 4 pi r squared is the formula for surface area. Right, so if we can get 4 pi r squared by itself, then essentially we found surface area. So divide both sides by 2. 32 pi divided by 2 is 16 pi equals 4 pi r squared. And again, since surface area is 4 pi r squared, we can say, and we know that 16 pi is equal to 4 pi r squared, so therefore surface area is 16 pi square centimeters. Okay. Number 3. Says a particle moves along the x-axis, so that its velocity is given at time t is given by here's our velocity function. Find the acceleration of the particle at time t equals 4. So if we want to find the acceleration at 4, we have to go and find the derivative and plug in 4. So a of t, remember the derivative rule for ln of u is simply u prime over u. Right. Or 1 over u times u prime. So the derivative for 2t t squared minus 3t plus 3 is simply 2t minus 3. Okay. And then over the original u value. Okay. So now we can evaluate the acceleration at 4 seconds. So or 4 when t is 4. So plug for n for t, and we get 5 over 7 for acceleration. Okay, for part B, find the times at which the particle changes direction. So changing direction, this is talking about determining when the particle is motionless. So we set velocity equal to 0. Okay, and then we're trying to solve for t. So remember, natural log is simply log base e. Converted to exponential form, e to the 0 is equal to t squared minus 3t plus 3. E to the 0 is simply 1. And going through factoring, we subtract 1 from both sides. T squared minus 3t plus 2 equals 0. Factor, we get t equals 1 and 2. So we put all the information, critical points on the sign line, as well as our endpoints. And then we can test with our velocity function. So here I can plug in 0.5. 0.5 will give me 2 negative values, so that's positive. 1.5 will give me a negative and a positive, so negative. Any value from 3 to 5 will give me 2 positive values. So I know that particle, positive means moving right, negative means moving left. So I know that the particle will travel left from 1 to 2 because my velocity is less than 0. Okay, number 4, we have a spherical balloon. It's inflated, so that's volume's increasing at a rate of 20 cubic feet per minute. How fast is the surface area of the balloon increasing when the radius is 4 feet? Okay. So let's put the information, the formulas that we need: volume formula, surface area formula. Volume is increasing at a rate of 20 cubic feet per minute, so that's dV dt, and it's increasing, so we're going to keep that positive. And we're trying to find ds dt, right? Rate of change of the surface area. So when radius is 4 feet. So let's work with our volume formula. So dV dt is equal to 4/3 pi 3r squared dr dt. This is a derivative. 4/3 pi is the leading coefficient. 3's cancel out, so dV dt is 4 pi r squared dr dt. Okay. Let's see, we have radius, we have dV dt, so then we plug that information in, and then we try to solve for dr dt. So dr dt is simply 20 over 4 pi times 16, so simply 5 over 16 pi. Okay. How fast is the surface area increasing? So we're trying to get to ds dt, but to do that we have to go through derivative rule. So s becomes ds dt, 4 pi r squared becomes 8 pi r, or you can think that's 4 pi times 2r dr dt. So to find ds dt, we need dr dt, which we have from our previous portion. So replace dr dt with 5 over 16 pi, cancel out the pi's, and multiply the remaining terms, and we get 10 square feet per minute.